Hey everyone. So previously we have been talking about the salt preparation methods. We know their salts could be soluble or insoluble. We know the insoluble salts are generally silver chloride, silver bromide, silver iodide, and even barium sulfate, calcium sulfate. We know all other salts are soluble, and generally all the sodium salts, all the nitrate salts, all the potassium salts are always soluble. We know that for salt preparation, the insoluble salts are made by the ionic precipitation method. We know the entire detail of the ionic precipitation method from the previous video. In today's video, we're going to be talking about the soluble salt preparation. So let's go back to that flowchart we know. And for soluble salt preparation, we can have still two methods for us. The soluble salt preparation can be done through two methods. The first method is a titration method. The second method is an acid plus insoluble base. So when we talk about the first method, that is known as the titration method, where we actually use an alkali plus acid. So it's a whole titration method where alkalis and acids react to give you the required salt. It is used in the case where you have lithium hydroxide as an alkali, or sodium hydroxide as an alkali, potassium hydroxide as an alkali, or ammonium hydroxide as an alkali. When you have a salt with these four alkalis needed and any acid, you go for the alkali plus acid method, which is the titration method, because these four alkalis are possible: lithium hydroxide, potassium hydroxide, sodium hydroxide, and ammonium hydroxide, and you can go for any acid that you want. The other method is known as the insoluble base plus acid method. Insoluble bases are used when you do not have an alkali available. For example, you don't have any alkali for magnesium, so you go for magnesium oxide, you go for calcium oxide, you go for zinc oxide, you go for copper oxide, etc. And then you use whatever acid you need. So in current video, we're going to be talking about the titration method. So right now, let's recall the fact that titration is used when you have an alkali possible, when you have an alkali available, and you have any acid. So you need an alkali and you have an acid. Why not the A of the alkali should be capital? Yeah. There are four alkalis possible, which is lithium hydroxide, you have sodium hydroxide, potassium hydroxide, and ammonium hydroxide. These four alkalis are all liquid. They are all aqueous. Aqueous alkalis, they dissociate in water to give OH ions. So they give OH ions in water. You can have any acid of your choice. Generally, the acids that we use are hydrochloric acid, nitric acid, or sulfuric acid. These are the most common acids. They go in water and give you aqueous. They give you H plus ions in water. Coming back, what you do is you always get a conical flask and you take the alkali within the conical flask. No matter which ever alkali you want to use, you just take a conical flask. So this is your conical flask. This is a conical flask. You take your, I'll label it as well. So I've got my conical flask and I'm going to be taking my acid over here. You can take either of those. So it's a conical flask and you take the acid within it. So your acid has to be within the conical flask. Which acid? Whichever acid. You generally take, normally you take 25.0 centimeter cube of whichever acid you want to use. Then what you do is you add few drops of indicator. So you also make sure to add few drops of indicator over here. You have a dropper, you add 2 drops of the indicator over here. So this is my dropper, guys, and within the acid you add few drops of the indicator. Now what you do is, once your conical flask is ready, you titrate it with an alkali. So you take your conical flask, you place it under a burette. Now you should know what a burette is. A burette is an instrument. It's a piece of chemical apparatus which you use to transfer any liquid chemical. It has a tap over here. It has a tap. It has even graduation. It has even marks on it. And that is your burette, guys. So this is your burette. I'll label it as well. This is your burette. You have your alkali over here. You had your acid plus indicator. This was step 1 earlier. Now this is step 2. You transfer your alkali from the burette into the conical flask, drop by drop. So you transfer alkali into the conical flask, drop by drop until a color change, because the color change indicates that the reaction is complete. Once your reaction is complete and you see a change of color, for example, whenever you use an indicator there has to be a color change. So for example, initially the color was colorless. Let's suppose this is a very light shade of blue, but it indicates color. It indicates colorless solution. But let's suppose after the titration is done, you get a pink solution because the indicator changed the color. Now what you do is, you repeat the titration without the indicator. So first you added the acid, you added drops of indicator, you titrated with the alkali. Now you repeat the titration without the indicator. So in step 3, you repeat the titration without the indicator, because even indicator is an impurity, you don't want that. So repeat the titration without indicator. In fourth step, now fourth step is really interesting, because in the fourth step you have your salt solution ready. So you have your salt solution with you within the conical flask. This has, let's suppose this is my salt solution. I'm giving it a blue color, but generally it is colorless, obviously. So you have your salt solution over here. Now how do you get your salt out of it? You perform crystallization. So in step 4, you transfer the solution into a china dish. You heat it until saturation point, and then you cool it for crystallization. So on a china dish, you heat it. Let's suppose this is gonna be your china dish. This is your solution. I've got my china dish. I'm heating my solution till the point of crystallization, till the point of saturation first. China dish. In step number 4, you heat it until saturation point and then cool to obtain crystals, because all the water evaporates and all you're left with is the crystals of the salt. Once the water is gone, once the water has evaporated and your salt crystals are there, then you get your crystals on a piece of filter paper and then you dry it within the folds of the filter paper. So finally you will have your filter paper. I don't know why I'm drawing filter paper with an orange color, but let's say this is the filter paper, and you have your salt solution over here. Salt crystals over here. So let's suppose these are the crystals of the salt, and you dry it using the folds of the filter paper. salt crystals, and they are dried. So make sure you tell about all the points. You mention the acid, the name of the acid. You mention that you added indicator. Then you mention the word titration using alkali. Then in step 3 you say repeat the titration without indicator. Then you mention heating it in a china dish and then cooling it for the crystallization process, and then mention drying using folds of filter paper. This happens only for the salts of lithium, sodium, potassium and ammonium, because we have only these 4 alkalis possible. Which salts am I talking about? I'm talking about all the lithium salts like lithium chloride, lithium nitrate and lithium sulfate. I'm talking about sodium chloride, sodium nitrate, sodium sulfate, and I'm talking similarly about potassium salts, and I'm talking similarly about ammonium salts. So I hope this video is clear for us, and in the next video we'll be talking about the next method, which is the insoluble base method. So guys, stay tuned.